Our new entry is an introduction to quadratic functions and quadratic equations. So you might be asking yourself, what is a quadratic equation or function? A quadratic function is in the form ax squared plus bx plus c, where a does not equal 0. So a, b, and c are just any number, but a can't be 0. If a was 0, then this term would go away, and it would be bx plus c, which is like slope-intercept form, mx plus b. Okay, it doesn't make the shape that a quadratic function would make. Examples of quadratic functions would be something like y equals 3x squared, where a is 3. You don't necessarily need a b or a c, so that's just y equals 3x squared. Another example is just having y equals x squared plus 9. In this case, a is 1, b would be 0, and c would be 9. And our last example, where we have a, b, and c, x squared minus x minus 2. And that might look familiar to you from when you were graphing or from you were factoring. So let's kind of get down to what a quadratic function looks like. So we have what's called the parent function, which is y equals x squared. It's called a parent function because everything stems off this one graph. Okay, so if I were to add 9 to it, right, it would be this graph plus 9. If I were to add a 3x here, it would be x squared, and then 3x would change it a little bit. So we always start with x squared, and everything we start adding around it changes that shape. So let's graph the parent function. Now, when you graph quadratic functions, what we're going to do is we're going to start by actually making an xy table. So we're going all the way back to making an xy table. Let's do x and y. And if you remember, we did nonlinear functions a while back, and I had you choose 5 values, 2 negative, 0, and 2 positive. We're going to do the same thing here. So let's choose negative 2, negative 1, 0, 1, and 2. And we're going to find the x values. So my parent function, right, is y equals x squared. Well, negative 2 squared would give me 4. Negative 1 squared would give me positive 1. 0 squared would give me 0. Positive 1 squared would give me positive 1. Positive 2 squared would give me 4. And if I plot those points, I'm going to use blue here. If I plot these points, I have negative 2 up to 4, which is there. Negative 1 up to 1, 0, 0. And then I have positive 1 up to 1, and positive 2 up to 4. So look what happened in this graph. It goes down and then up. If we were to list out all these numbers, this one goes 4, 1, 0, 1, 4. If I were to add in a 3, 3 squared gives me 9. Well, negative 3 should give me 9 as well. So it's symmetrical about this point here. And that point's called the axis, or that this line here is called the axis of symmetry. And it's hard to see because I got this black line here. But right here is what's called the axis of symmetry. Okay, because they're symmetrical across this line. It's almost like a reflection of itself across here. If I were to fold this, it would fold on top of itself. So if I go up one this way, it's going to be up one that way. If it's up to 4 here, it's up to 4 there. If it's up to 9 here, then it's going to be up to 9 there. So really when I'm graphing quadratic functions, if I know where it's symmetrical, I only have to do one half the line, and then I can just copy the other half over. And as we start to do more and more of this, you'll kind of get the hang of where is it symmetrical and what points do I have to graph. We also have what's called a vertex. So a vertex is the point. Here the vertex is there. Okay. It's the point that's on top of the axis of symmetry. Now, it can either be a minimum value or a maximum value. So you'll notice that this graph goes down and then it goes up. It never gets lower than 0, 0. It's as low as it goes. Because it goes down and then it starts going back up. So this one is called a minimum. Okay. So a minimum would be at 0, 0. And we're going to write those vocabulary words right here. And it's important to note here one definition you're going to hear quite often is that this shape, this U shape that it creates, is called a parabola. P-A-R-A-B-O-L-A. Okay, we call that a parabola. So if you ever hear the word parabolic, it just means it makes a U. It could be an upside down U, but it makes a U. Okay, and then those vocabulary terms that I want to go over. Axis of symmetry, that's the line that cuts the parabola in half. Right, so this half is a reflection of this half. And the vertex, it would be the highest, called the maximum, or the lowest, called the minimum, point on the axis of symmetry. So if it's symmetrical here, we have a point on it, and this is a lowest point, so we call that a minimum. Okay, I want to show you something on Desmos.com, which is an online graphing calculator. So we have this parent function y equals x squared, which you can see in red. Now, what if I were to multiply x squared by 3? What do you think is going to happen to this parent function, right? This is where we start. Everything we do to it makes this parent function change. So let's take a look. If I were to graph y equals 3x squared, that's in blue. Notice how it goes up faster, right? So my parabola gets skinnier. Now what if instead of 3, I were to multiply it by 1/2? It gets wider. So it's not going up as fast. So this term, which is the a term, right, the number in front of x squared, shows how wide or how skinny that parabola is going to be. And you can see it right there. So that's 3x squared, and then the green is 1/2 x squared, and then the red there that's in the middle, that's our parent function. Okay. Now, what if instead I have my parent function here, y equals x squared. What if I were to just simply add 4 to the end? What if it was x squared plus 4? Well, let's take a look at what happens. It just went up 4, right? It didn't change how wide it was or skinny. It just moved the whole thing up 4, right? And if we look at these like comparatively, if we put them next to each other, when x is 0, our parent function would be 0, so 0, 0. In this one, when x is 0, y would be 4. Because what we're doing is we're taking every y value we get here, and we're adding 4 to it. So that's why every single point, if you look, is 4 above. Right? So this point, 2, 4, is really 2, 8. 0, 4, or sorry, 0, 0 is really 0, 4, because I'm adding 4 to every single x coordinate, or sorry, y coordinate. Okay, so everything we do, which is what I'm trying to show you, is everything we do is based on this parent function and then changing it somehow. Okay. So let's go back here. What if it was, instead of plus 4, what if it was minus 4? Well, now look what happened. It went down 4, right? So this really just changes where the function is, like its height. Plus 3, plus 4, plus 5, plus 6, plus 7, plus 8, plus 9, right? It's just getting either higher or lower. It's not going left or right, and it's not getting skinnier or wider. Right? It's just going up or down. Now here, if I were to say y equals 3x squared, right? It's getting skinnier. 4, 5, 6, 7, 8, 9, 100, right? Okay, it's getting skinnier. And then if I were to make this smaller, so third, fourth, we want to see it. Right, 1/2, 1/3, 1/4, 1/5, 1/6, 7th, 8th, 9th, right? It's getting wider. If I zoom out, you'll really be able to see how wide that gets. Continuing our work with quadratics, we have y equals negative 2x squared, and we're going to be graphing that one. So we want to make a table. So let's make an x, y table. And we want to choose values, so let's go negative 2, negative 1, 0, then 1, and then 2. And then we're just going to fill in for our value. So I know y is negative 2x squared, so that's negative 2 times negative 2 squared. Well, negative 2 squared is 4, so it's negative 2 times 4, which is negative 8. And I know they're symmetrical, okay? And I know that they're symmetrical along this line here. Once we start adding like negative 2x squared plus 3x minus 4, those axis of symmetry changes, okay? But if it's strictly x squared, okay, or x squared plus 3, okay, the axis of symmetry is always going to be in the middle here, okay, which I showed you on those videos how it changed. So if this is negative 8, that means 2 must also be negative 8. Let's do, or evaluate when x is negative 1. So negative 1 times negative 1 is positive 1, and negative 2 times 1 is negative 2. And then lastly, 0 times 0 is 0, and negative 2 times 0 is still 0. Alright, so it goes negative 8, negative 2, 0, negative 2, negative 8. And let's see what that one looks like. So the point negative 2, negative 8 is negative 2 matches with negative 8 right there. And then negative 1, negative 2 is here. 0, 0 right there. And then it's symmetrical, right? So I can just do this, right? This is 2 away from the line, that one's 2 away from the line. And I can just graph that parabola. I know it's a U shape. Okay, so you can roughly make a U shape. It's hard to do imperfect. So now let's talk about this line. What is the vertex? Well, it's at, right? The axis of symmetry is here. the vertex is going to be the highest or lowest point that's on there, and it's going to be 0, 0. Now, is it a maximum or a minimum? Well, it is actually a maximum in this case, right? It's the highest point that's on there because this is flipped down. So in this case, it is a max. Since we're talking about functions, and if you recall functions, there's domain and there's range. Well, range, which is those possible y values, what are the possible y values for this function? Where are all of the y values, right? These are the y values here. Where are all of these points? They're always negative, right? So the range are the values of y that are less than or equal to 0. Okay? It can't be positive because they're all in this negative space. Domain are the possible x values, right? And this thing can keep going, right? Even if it was 10, I could do negative 2 times 10 squared. It'd be a big number, but there's no really restrictions on my x values that I can use. But no matter what number I put in, it's never going to be up here. Okay, so it's going to give me a negative value. So my range is y is less than or equal to 0. Our last example is graphing y equals 1/2 x squared plus 1. So again, I'm going to use the table of values. And I want to choose x values. That's not going to give me a fraction. And if you remember when we started doing graphing by a table with slope-intercept form, I said to choose multiples of the denominator, so multiples of 2 in this case. So that's what we're going to do here. We're going to choose negative 4, negative 2, 0, and then 2, 4. And let's evaluate. So I know my function is 1/2 x squared plus 1, so that's 1/2 times negative 4 squared plus 1. Negative 4 times negative 4 is 16. One half of 16 is 8, plus 1 would give me 9. So negative 4 goes with 9. And I'm just keep on evaluating. Negative 2 squared is positive 4. 1/2 of 4 is 2, plus 1 gives me 3. And 0 squared, so 1/2 of 0 squared is 0. So that is just 1. Right? And then I know that it is symmetrical. So negative 2 gave me 3, which means positive 2 is going to give me 3. Negative 4 gave me 9. Positive 4 should give me 9. Okay? So let's plot these points now. Negative 4, positive 9. So negative 4 up to positive 9. And negative 2, positive 3. Negative 2, positive 3. 0, 1. 2, 3. You can see they're symmetrical, right? 2 away, 2 away. If this is 4 away, then that should also be 4 away, which makes sense because this is the point 4, 9. And I'm just going to graph that parabola. And there we have it. So, again, what is the vertex here? Here's the axis of symmetry. What is the highest or lowest point? Right? Vertex is here. So that's the point 0, 1. And is it a max or minimum? Well, it is the lowest value here. Since it's the lowest value, it's going to be a minimum. And what about the range? So let's look at the graph. They're all up here, right? So we know they're positive values, but because I did this +1 here, this line's never going to go below 1. Right? There's this imaginary line, this threshold, where this line is not going to go down, right, or past. So my range is going to be the y values, okay, and it's not going to be that are greater than or equal to 0. It's greater than or equal to 1. Okay. If this line was up here and it went branched that way, it would be greater than or equal to 6 because it never goes down here. Okay. If the line was all the way down here, we had a parabola like that, the range would be all the y values greater than or equal to -5 because it never goes below here. So that's what we are looking for when we talk about range. What are the possible values?